Hello, everyone. I hope I'm audible to everyone here. Uh, so in this whole session, we are going to see a very good example or a very good use case of AI in terms of intrusion detection system, and we will try to understand why actually we need this explainable AI. Why actually this thing is very important. But I hope you all can hear me, right?
Prabhat, yeah, we can hear you. I think if I'm just feeling this or other guys are also feeling this, that your voice is not very much clear. It is in intervals, it breaks down.
Okay. So now is it clear?
Yeah, it's fine now.
Uh-huh. Okay, so what I was telling a few seconds back was we are going to see a use case of AI in terms of intrusion detection system, and then we will see why actually this explainable thing is very important, and we will understand the whole scenario from industrial IoT point of view. So before I start, so does anyone know actually what this industrial IoT is, or what actually it is all about? Or anyone have heard about industrial IoT, or at least about IoT, or everything is new?
IoT, yes, but not in this industrial context.
Okay. So if I talk about IoT, so IoT actually has certain devices or objects, and the ultimate goal of Internet of Things or IoT is to collect or sense data from its environment. For example, you may have a temperature sensor in your classroom, which actually can help you to collect the current temperature of the classroom, and based on which you can control the heating system which is there in your classroom. So this is one of the example of Internet of Things, where you actually want to connect the devices with internet to collect or gather some data, based on which you want to make some decisions. Okay, I have some chat message. Okay. And now let me tell you what this industrial Internet of Things is. So when I talk about industrial Internet of Things, it is more about manufacturing industry, means manufacturing plants, or some industries where actually some production is being done. For example, a car manufacturing unit, where the whole car or the automobile, means the whole car is actually is manufactured from starting to its delivery. Yes, so it has some concepts related to Industry 4.0 and 5.0, which I can see in chat. Yes, so we are going to come up with this, what exactly this Industry 4.0 is, and how actually it differs from industrial Internet of Things. But in simple terms, why we are here understanding this industrial Internet of Things is because you are going to see in every manufacturing plant, whether it is a Pepsi or a Coca-Cola bottle, to a car, or maybe to a Boeing engine, everywhere you are going to see automation is there. And when we talk about automation, it's about data driven approach. Means there will be some data, whenever you are doing some computation or processing, some data is going to be generated, and you want to analyze that particular data, based on which you want to perform, or you want to take certain decisions. So this is the main reason why actually we are trying to understand what industrial Internet of Things is. And I can give you a simple example of industrial Internet of Things. Like, for example, there can be multiple different kinds of sensors in industry. One can be vibration sensor. So the role of vibration sensor is to check what actually is the current vibration of uh, any device or any equipment that is being used in a manufacturing plant. Let's take an automobile manufacturing plant. So this vibration sensor is going to tell whenever it is doing its intended task, it is going to tell you what is the current vibration of of that particular equipment when it is doing its task. And like this vibration sensor is going to have a threshold, means under normal condition what is the certain values of that particular vibration sensor. And if when it is operating in real time, if the value which is coming from that vibration sensor is high or it is low, based on which certain decisions can be taken. For example, in under room temperature, if the vibration sensor tells for a particular equipment in a car manufacturing plant, there is a very high vibration is happening, it means that particular equipment can fail and there is a need of certain maintenance, or you can do predictive maintenance on the whole system actually, based on this vibration sensor. So if you see the whole story, what I'm trying to tell you here is this industrial Internet of Things is about the automation, and because of automation in industries, it is more towards industry. It's not about consumer things that we operate in our day-to-day life. For example, smart cities or self-driving car. So we are not talking about consumer Internet of Things. We are more towards industrial and industry. We are more concerned about industry equipments here. However, if you see the global market of industrial IoT, you're going to see this is increasing every year, and the potential of this industrial Internet of Thing market is going to rise from 0.5 trillion to 1.3 trillion by 2030. So you can see it has a very big market, especially in countries where the manufacturing is one of the main source of income. For example, China, Germany, and other countries are also there. So they have their own plants in which they do the manufacturing, and because of this, you can see there is a very good trend, and it is actually a very good place to look for maybe for a job or for any other thing. So if somehow if anyone actually gets aligned with industrial Internet of Things, it is a very good market and to study and to work actually. But there is a difference, and there are some concepts. If you see in chat, Mohammed Zohaib has mentioned Industry 4.0 and 5.0. We will not go to 5.0 right now in this session. We will limit to 4.0. So if you see this Venn diagram, in this Venn diagram, actually, I have what I'm trying to convey is this industrial Internet of Things is a subset, is actually a subset of IoT. So in IoT, if I talk about the general definition of IoT, basically it is a network of physical objects, and these physical objects can be anything, starting from your room temperature or to proximity sensors and so on. Means different types of sensors, I mean. And these sensors are actually embedded with some softwares which collects the data in real time, and then it converts that data into analog or into digital format, and then it transmits that data to the cloud or to the nearby edge, to the nearby devices, where actually it can make some decisions. And this whole connection is being done over internet. So you are connecting some devices with internet to collect some data in simple terms. So this is all about IoT. And within this broad term of IoT, we have this industrial thing, or you can say some smart devices are there which are more related to industry, or they are industry oriented, and we are calling them as industrial Internet of Things. But there are two more concepts. If you see, so in this Venn diagram, there are two big circles. One is for IoT, and other is for a cyber physical system. So what actually cyber physical system here is? Okay, so so this cyber physical system actually is going to integrate this sensing thing. It's not only about how you collect data from your real time. It's about collecting data from your real time, then then it's also about computation, how you are going to perform certain computation on it. It also talks about some control, how actually you're going to take the decisions. It is also about networking and analytics. And ultimately, it is going to integrate all these sensing, computation, control, and networking into physical objects and infrastructure. So it is going to have its own infrastructure in which humans are also included, which are one of the which you can say are one of the which are the part of the whole architecture, and they are going to take some decisions based on their the whole working. So a good example of cyber physical system is a robotic arm. So if you see the robotic arm in any industry, or if you have seen any online movies or a video of a robotic arm, how it actually works, it takes a command, means it sends its environment, what is happening, and based on its environment, like for example, if the goal is to uh, pick a box and to drop it to a different place. So it is going to sense whether that particular box is there in front of it or not. Once it senses it, then you have a certain algorithm design which actually moves the robotic arms, and it picks that particular box from one place and it drops to another place. And this whole computation which this robotic arm is performing right now is being done in with using internet. So it is being connected using internet, and this is how the whole robotic arms does. So it's not only about sensing, it is also about performing computation, controlling, and about the whole networking. So this is why in my previous Venn diagram, if you see, we had a very big circle of CPS, cyber physical system, and Internet of Things, because these two are very broad concepts. And when you merge these two concepts together, then in between we have this Industry 4.0, which actually comes from Industrial Internet of Things only. So what is Industry 4.0 here is like it is about the this evolution of industry from starting from the steam engine. If you go back to 80s, we have these steam engines, and from steam engines now we have this automated robotic arms to perform different activities in day to day or real time. So when actually you merge this IoT with cyber physical system, you get a new paradigm which we call as Industry 4.0, and the ultimate goal is to use the concepts of IoT and cyber physical system to improve production efficiency in any manufacturing plants or in any smart factories. But ultimately, what things I can tell you should get from this this Venn diagram is this IoT, this IIoT, Industrial Internet of Things, is basically a subset of IoT, and it sits between inside IoT, and it is more towards it talks more about industrial applications rather than consumer oriented applications. So till now, like, do you have anything to ask, like, or do you think, or anything like you are not understanding here in these four concepts? And why I have taken this concept, I can tell you why. The reason was because this automation is something which is happening everywhere, and this is a very beautiful example of automation, and which is actually happening in our in industries. And everyone, like every human being, we as a human being, we are using some certain products which are coming from industries. I think almost all products are coming from industries. So we should know actually how these things are actually working. So do you have anything to ask? Maybe you can, if you have something to ask, you can put on chat, and then I can give the answer. But how actually this works? So if you see this diagram actually tells you how this is a a diagram which is going to tell you how different participants or different things are connected in the whole IIoT architecture. And there are multiple different types of architectures available. It actually depends on the person where where actually he wants to work. For example, if I want to work on like if my ultimate goal is to work on the bottom layer where we have the devices, the physical devices, and I want to work I want to develop a certain AI-based algorithm which actually can see how the data is being transferred between the device to the end business layer where actually some application is being there. In this scenario, I think the best case will be the three-tier architecture, in which we have this edge layer at the bottom, and then we have a platform layer which actually helps you to send your or which actually helps you to send and share messages that you are going to collect in real time from your devices to enterprise business applications. Are there any examples of leading platform for connecting different sensors in industrial IoT? I think there are so many. Means you can have your own. You can create your own platforms. You can. But right now, what I can see is cloud-based There are so many cloud-based platforms. Azure is there, and many other platforms are there, with which actually you can use to connect uh, this whole three-tier architecture. Yes, we can say IoT is the enabling technology for Industry 4.0. Uh, for Industry 4.0, yes, because if you see the previous Venn diagram, if I go back in the previous Venn diagram, uh, Industry 4.0 actually sits between this IoT and cyber physical system. So the whole Industry 4.0, the yellow part, which is shadow part, you can see it is under IoT only. So it actually uses this IoT as its core technology. So it depends. It depends in which context actually you are using. For example, there can be certain platforms in which you want to where you want to connect your equipments with cloud. For example, for mission critical systems or for any other for mission critical system which includes spaceship and all, you may have your own inbuilt platforms. You may have your own platforms. Yes, cybersecurity. I will come. I will talk about cybersecurity in this session. Why, like, it's not only about our mission critical system. When you are using the normal manufacturing plant, in normal manufacturing plant also, you want to use this cloud because you want to have this connection with cloud. So that everyone can access remotely the whole data, and it is not like you need to be physically there to perform the whole computation or to do analysis. But for mission critical system, it actually depends, and for most of the mission critical system, it is closed environment where actually you have your own platform within that environment, so you don't share data on third party cloud. Everything is you have your own environment within that organization. But if even though you have your own organization, means even though if you are using your own platform within a particular boundary, you can use this three-tier architecture, because ultimately there will be some platforms which are going to take the data from the edge devices, and based on which it is going to perform certain computation. So how this tier reference architecture works is like I told you, there can be multiple layered architecture. So it's not fixed three tier. There is 2 tier, 4 tier, 5 tier. So it actually depends on which part of the whole communication you want to work, or where actually you see yourself as a researcher, or as an analyst, or as a business or in a business from business point of view actually. So the whole architecture consists of edge platform, which includes which actually has some sensors, controllers, actuators, which actually are interconnected with each other using a local area network. And then there is an edge gateway, which actually connects this sensors directly with a large network, which we are calling it here as a platform tier. And this platform tier actually gives you a global coverage, means there can be multiple different subsections. There can be multiple different subsections. If I go back to the diagram, you can see there can be multiple different sensors working differently in the same organization or in different organization, and you want to connect this. You want to connect the whole data from different parts, from part 1, from part 2, and how you actually you're going to collect the data. So you're going to collect this data from this platform, basically from different subsections. And ultimately, you are going to have a business platform sitting on the top, from where you are going to from where you're going to take some decisions, and there will be some applications which are going to use the collected data, and it is going to send you some controls or some decisions based on the analysis which is being done on the top layer. But now, as I talk about, like we are going to see intrusion detection system in this industrial Internet of Things. So it is about cybersecurity only. And when I talk about cybersecurity, so the first thing that comes in my mind is CIA TRAD. So confidentiality, integrity, and availability. So as you see, we have done the automation of the whole manufacturing industry, and it is now the whole, because of this automation, now it is being changed to from a static to a data driven approach. So everything is being done using the data that you are going to collect. So when we talk about data, it is and communication, it's all about cybersecurity, and cybersecurity means we are more concerned about CIA TRAD, where C is confidentiality, I is integrity, and A is availability. And in this context, what I mean is the data. You need to protect, actually this confidentiality means you need to protect the data from unauthorized access, and I is integrity, means the data should be complete. It should not be corrupted when you are doing this. Once you are transferring the data from sensors to the business or the top layer. And A is the availability, means the authorized users should, this data should always be available to the authorized users. And this is very important because the users are all, means they always pay a very huge money, and they always want that data should be available. So if somehow you can achieve this CIA in the whole communication of the data, it means the whole infrastructure is secure. And this is actually what this slide talks about security properties that we need to consider when we are doing this automation. And these are some key points that I have taken. So these are some generalized things that actually are going to happen, but there are more things or more use cases that actually can cause some security issues in the whole network. For example, the first line, which it talks about, IoT devices needs to be a temper resistant against potential physical attacks, because if the devices which are there at the bottom, if they have been tempered, it means they are not going to collect the data for which they have been programmed. And this actually can give you the data which is tempered data, from which actually you cannot make the right decisions. And this actually includes unauthorized reprogramming and passive secret stealing. The other is the storage of IIoT device should be protected against adversary by keeping the data encrypted. So whenever the data is being sent from your end devices to the business layer, it should always be encrypted to ensure confidentiality. And so this means the communication network from where the IIoT devices communicate with the whole business tier, it should be secured. So no one actually can. The data should be transferred in such a way that no one or the third party should not access the data in between. And yes, so this is very important. And the next is the IIoT infrastructure needs efficient identification and authorization mechanism. So this is one of the way by which you can actually guarantee CIA TRAD. If you have a very solid identification and authorization techniques, then it means the only authorized entities can access the whole IoT resources. And like I said, availability. So the system should be available with the normal operation, even if there is certain physical damage to the devices by some unknown or malicious users. So if we can achieve these things, so we can guarantee robustness in the whole IoT infrastructure from cybersecurity point of view. But what is the challenges in having these techniques? So it turns out that the conventional security solutions that you want to use in IoT context will not fit. For example, if you use this end-to-end encryption technique from device to your business layer, what is going to happen? Then the analytics tool that you want to use that may not work directly with the encrypted with the encrypted messages. Then you need to decrypt the message, and then you need to perform certain tasks. And for example, if you have your own firewall or you have IDS, then this firewall and IDS may not work directly with this encrypted messages. And because everything was encrypted, you may get high false alarm rate. For high false alarm rate, even though it was a normal message, but your intrusion detection system or your firewall says it is coming from a malicious user, and it will raise an alarm. So this is one example. Like, you cannot have end-to-end encryption technique. You cannot directly implement end-to-end encryption techniques. And if you are implementing it, then this is going to be one of the consequences. Other is this authentication and access control protocols. They actually cannot deal with different types of attacks. For example, denial of service and distributed denial of service are some of the attacks. So what is denial of service here is like, you have one system, and one system is now continuously sending some request to a particular URL, and because of this request, now this the URL or the server now is overloaded with this particular with this particular messages, and now it cannot process any further message. And because of this, now the actual user cannot the actual user who want to use this resource cannot use, because the server is not responding anymore. But when you are doing the same thing from multiple different locations, we call it distributed denial of service, where actually you are sending bogus messages to the server, and the ultimate goal is to make the server uh, to take the server down, so that it cannot respond to the actual users. So what can be the solution in this case? So in this case, what I think is intrusion detection system is one of the tool which actually you can put on your network, and it can track or it can trace the incoming packets or incoming messages, and it can tell you whether the network or whether the incoming message actually is coming from a normal user, or it is coming from a malicious user. So just to give you a general information about intrusion detection system, because everyone has their own, like everyone is working on a system. You are using a firewall, but but from an organization point of view, every organization uses an intrusion detection system, which ultimate goal is to identify the traffic in the network which is coming from a malicious user. So it wants to differentiate the traffic that is different from a normal to a malicious user. And once you can differentiate, actually, this traffic is coming from a normal and this traffic is coming from a malicious user, it turns out that you can eliminate those malicious traffic, or you can just block those particular source IP address, so that you will not get any request again from that particular address. So this actually what is intrusion detection system, and we can classify intrusion detection system based on two things. The first is about from the information source, means where actually you are putting your intrusion detection system. The other is based on the detection method, what kind of methods your intrusion detection system actually uses. So when I talk about the placement, where you want to place, so you can place your IDS on a single host. For example, on my system, you can have an IDS on your own system, and if you are having IDS on your system, so it means it can only work for your own host. But if you are putting this IDS on the whole network, okay, so I practice. I have seen the most difficult point being the network friction of the physical asset from production units. How do you see? Okay, okay. So can you explain what exactly you want to say? I practice.
Yeah, I work in an industrial company, so in a way this has been very practical problem that the separation of physical assets from cybersecurity point of view is needed, and then making IoT data flow easily. It means that it's kind of a very practical problem that the firewalls and all the setups and the layers that are needed makes it really complex to dig into what is probably the problem if there is an error. So because you can have a multiple moving parts, so perhaps this was just something that, is there any kind of a conceptual idea how this kind of a problem could be avoided in that sense, if you understand what.
So you mean when you have this the whole network, and in the whole network when the data is flowing, so do you want to know like about this IDS or the firewall, about the placement, you mean?
Yeah, that maybe how that could be sort of taken into account, that this that you showed the layered structure, which kind of is a standard one, and in makes it sense. But how should that be thought from cybersecurity point of view? That how you make that, because in real life you probably will be having a network policies and firewalls in between, and so it makes it kind of a practical work kind of a problematic in that sense, that there is so many layers and so many even organizations can be involved, so it can be a little bit difficult to manage.
Yes, you're right. You're absolutely right. So actually, it depends. It depends on the scenario and the whole architecture that is being used in any organization. For example, if I talk about this host ID, so if you have developed your IDS and and you want to have that IDS on a particular system, so which actually takes the whole control of your infrastructure, you can put that IDS there. But if you see, if I go and the second one is the network one. So if I go back here to the same diagram, if you see, we have this edge gateways, which actually connects different actuators and sensors in different sections. So you can also deploy this IDS on this IoT edge gateways, so that they can be very close to the edge devices, and based on which they can give you the decisions. Or you can also set up multiple layers of IDS. One you can put in IoT edge gateways, and the other you can put on the enterprise level, where actually you have your own systems, which gives you the decision. So it depends, like it is going to be a very complex thing, I know, but it totally depends on your infrastructure and how you want to use this IDS in real time. I hope it makes sense.
I can also comment from my experience. There are many companies who are deploying these lightweight IoT messaging protocols to avoid that there's different systems in different networks. So you could only open up data access for something like this MQTT messaging that is more lightweight, and in that sense should be more secure and work with some limited network. So I don't know if you will touch this MQTT in your presentation.
No. So those protocols I will not touch, because these are the protocols which you are referring, MQTT. So these protocols actually are being used to transfer data, because normal client server protocol client server protocol actually can work, but in this case, every means industrial network, they have their own protocols with the help of which they transfer data. And for IoT, MQTT is one of the most used protocol to transfer data. But again, it depends. Even though you are using this MQTT protocol, but the data when it is being transferred from one device to the other device, it is always transferred using internet. And when you have this internet thing being used, the chances of performing attacks or the chances of performing anything means to disrupt the connection or to corrupt the data or to make the host or the server unavailable, is the chances are very high. So it's not only about the the collection of data from the end device. It's about collecting and then transferring the data from the device to its intended location, which may be the cloud server, or it can be in between the edge devices where you want to perform some computation. But I will not go in that MQ means what protocols are being used to transfer the data. I will just give you a use case about this IDS, how this IDS is, and why we need this explainable IDS to understand things more.
Okay, thank you.
Yeah. So if I talk about, like I was talking about IDS, you can put IDS on your own system. And when you have an IDS on your system, we call it as a host. And when it's on the network, edge device, or between this platform tier, we call it network, because now it is analyzing packets from different sections. And similarly, based on detection method, what approach it uses to detect attacks, there are two different types of IDS. One is signature based. So in signature based, what we do is we know some patterns. For example, if the packet is, if a data is, or if a message is coming from a device which has the same source IP and destination IP. So in this is not normal. So source IP and destination IP should be always different. But if let's say they are same, it means it is not a normal user, and you can put it in an attack category. So you have a database, in which database you know some predefined rules, based on which actually you can classify whether the data which is coming from a host is a genuine, or it's a benign user. So the ultimate thing is you compare that packet in real time with your database, and if it says yes, it's not there, you just give a green signal, and the data is being transferred, or the request for which the data was coming, it can do its task. However, it has some limitations. For example, if that particular signature is not there in the database, then it's very difficult, means the security system can bypass. So just to overcome this, we have the other part, which is anomaly based intrusion detection system, which actually uses statistical learning, data mining, and machine learning and deep learning techniques to design intrusion detection system, in which you actually develop a model, and the model is trained on normal, using some normal data set, means how the normal data looks, as well as on how some attack data looks. So the model is being trained to know about normal as well as abnormal patterns. And based on which, now it filters the incoming patterns. So whenever any pattern, okay, data diodes could be one option. Okay, yes, maybe, yeah, you are right. Data diodes, you can be one option to securely transfer data. But again, it is going to depend to what certain environment you can use this approach. But normally, what you are going to see, every organization has this IDS and firewalls. So these are the two techniques which everyone, which means it is very common in every organization, and every organization heavily relies on IDS and firewall's decision. And this is why I have taken this topic here. And the second, yes, so the second one was anomaly based, where actually now you have trained your model using some data, and now your model knows to differentiate between the normal and as well as the abnormal packets, because it has seen those things, means in terms of data. And then you place your IDS on host, or maybe you can put it on a network. So you can have a combination of both. So now like you can have your IDS, which actually takes a certain input. Means the IDS is, if you see the whole intrusion detection system, we are more talking about anomaly based, where we are using some AI techniques to develop the model, which takes certain features and it gives you the decision based on its training, whether the traffic is normal or it's abnormal. Now, however, there is a limitation, and the limitation is like when you give certain input and you get certain output, you don't know what was the importance. Like there can be multiple things. First is you don't know how the internal this box is actually working. And when I say this internal black box, how it is working, it means you don't know why it is giving you for a particular instance, means a particular means for a particular let's say a message, why it is giving you attack or why it is giving you a normal. You don't know about this. This is first thing. And the other thing is we also don't know based on what features, like what were some features used. Like there will be different types of features whenever a packet is being whenever you get a packet from or a data from a source to destination. For example, if you see the whole packet, it can have source IP, destination IP, what is the protocol being used, TCP, UDP, and so on. What is the packet size? What is the port number? What is the timestamp? And so on. So there is a list of features when a data actually comes from one part to the another part. And now we also don't know, like based on which of these features your model is predicting, whether like it's giving the decision why we have got this attack or why we have got this normal. And we also don't know why we are achieving very high accuracy with this model and why it is generating low false alarm. So there is like, we don't know about the whole working. It is just, you just give certain input and you are just getting an output. And input in our case is the features, and the output is the prediction that we are doing. So this is the black box that actually we use to develop an IDS. So to answer these queries, we need to make our IDS explainable. And how actually we can make our IDS and why actually we need this explainable IDS is because, for example, this security analyst of Cybersecurity Operations Center can raise alarm based on the interpretation that they have done. For example, I can give you an example. Let's consider two scenarios, like in which your IDS, like if you have made your IDS, if now the IDS is explainable, it can tell you, okay, so based on this feature, let's say there is a source IP address, and now IDS knows based on source IP address, we can give high importance. We are giving high importance to source IP address. And if the IDS is raising an alarm, and if it is giving high priority to source IP address, then it means the chances of attack is high. And then this cybersecurity analyst actually can take their actions based on which, means they can bar the community, they can stop, or they can put that particular unknown source IP address in blacklist, and they can take their own decisions. And you can also have some other features. For example, this protocol type. You can have different types of protocol, TCP, UDP, and ICMP, based on which this communication takes place. Now, your IDS now, because now your IDS is explainable, now it is telling you like this feature is a medium importance feature. and based on which, yes, you can say like it is a medium importance feature, so it needs your intervention. So you cannot directly say means even though it is telling you like there is an attack with this particular ICMP. Let's say if there is an ICMP flood, so even though your IDS is telling you okay, so there is an attack, or it is detecting the attack, but and it is also generating an alert, let's say, but still in this case you can intervene in between, because you know this particular feature comes under medium importance feature, and certain and so on. You can also have certain some low priority priority feature, for example timestamp, or maybe you can have a port number based on your model, I mean. So you can classify these features, and you can know the importance of each features in contributing in actually contributing the whole detection of attacks. But how actually you can do this? So how we can do this is with the help of SHAP. So what is SHAP? So Shapley, so the SHAP is a Shapley additive explanation, and it comes from a cooperative game theory. And how it actually works, I can just give you an. We will not go into the mathematics, but we will try to understand how this SHAP works and how it can tell us whether the source IP, can I give source IP more important compared to port number or not? How it can do it. So we can take an example of a Kaggle game, and in which we can think of like we have multiple different players in our team, and each and there is a task that all team members has to complete. Now the thing is, for example, if there is a task and the guy who is in orange dress, if he is responsible to do the whole coding, and the light blue guy is responsible to perform data collection and to perform other analysis, and other two are helping out in other things. So it turns out that the guy who has written the whole code in the team should get more share. For example, if you win the game, the payout is $1,000. So once the team wins, it should be like the guy who has contributed more, he should get more reward. So this is called fair distribution. And Shapley can help you. This SHAP values can actually give you, means once you use this SHAP on your model. So what is model here? AI model is the game. We can assume that like this game is the AI model, and the team members are the features that we are going to give it as an input. So what this Shapley is going to tell you, it is going to tell you which person has contributed more, and based on which you can actually assign the payouts to the person who actually has contributed more. It is going to, and how it does it, so it is going to see the performance with and without that particular individual. Means, for example, it is going to check what is the performance of the whole team with orange and without orange, and similarly it will check for all subsets and sets that you can make from the whole team, and then ultimately it will come to a decision. For example, in our case, it is like the orange person has done the whole coding thing. So he is the most important person in the whole team for this Kaggle game. And as a result, he is going to get more reward compared to other person. So this is very important. And if I take the same example in IDS, which we were talking, so we want exactly the same thing. We have list of features, and we don't want to, and if we can somehow come to a point like this feature is very important, and if this feature if the weight on this on a particular feature, for example, a source IP address is high, it means the chances of getting and means the chances of getting an alarm, if the IDS is raising an alarm, it is going to be high. Means high in the sense we cannot deny that thing, and we should take actions based on the alarm that we are getting from the IDS. So how actually this thing works? So you have a data set, and you develop your own deep learning model or AI or any other AI model, machine learning model. And this model is going to take the data set, and it is going to do some predictions. Predictions in our case is normal or it is an attack. Now, this data set is the players and this deep learning model is the game. We are going to give this model to our SHAP. And this SHAP is going to tell you which features out of the whole, like let's say if we have 40 features, so which feature were the most important feature and which have contributed more, and based on which you can design your own your infrastructure, like for example importance that we discuss, high importance feature, medium importance feature, low importance features, based on which security analysts can interpret the decisions that are going to happen in the whole in the whole organization. So I have taken a use case. We have a data set. This data set is collected from an industrial environment, and it is a publicly available data set on IoT. And if you see this data set, it has 43 features. It starts from 0, and the last row label is this label actually tells you whether that particular instance is attack or whether it's a normal. So what we are going to do, we are going to give this features with its concerned instances to the model, to the AI model. It is going to be trained, and once it is trained, it is going to do the prediction. So you are going to have a training set, a testing set. So you're going to train your model, let's say with 70% of the data, and you're going to leave 30% data as it is to test your model once it is being developed. And based on this label, you're going to do this classification. Let's assume this. So in my case, means I will not go into details of this deep learning model, but this is in one of my research papers. So the model that we developed, actually now we can visualize this results. And how we can visualize? So if you see the diagonal, the dark blue and the light blue, it actually tells you about the right predictions that the model has done. And the yellow part, the cross thing, means from the left side, it tells you what misclassification that model has done. So if you see for normal instance, the model has done a very good prediction, as well as for attack, the prediction was very high. But for misclassification in terms of attack, it was less. But for normal, it was high. And if you see the overall scores, the accuracy was very high. Precision recalling and the other metrics were also very high. It was very high out of 100. So overall, the model was performing very well. But again, we didn't know out of these 43 features, which features were important. So what we did, we applied SHAP. And when we applied this SHAP, we got this summary plot. In this summary plot, actually, from this TON IoT dataset, we came to know, like the model which we have developed, it was giving more priority to destination port. The first one is TS, timestamp. Then it was giving more priority to destination port, then protocol, then DNS and service, and so on, and destination IP and so on. So now, like out of 43 features, it's not about all 43 features. It is about maybe about these 10 features, and maybe about this first 3 features, based on which you can make your own internal assessment. You can have your own internal assessment where you can put some features in high importance feature class. Second can be medium importance, and third can be low importance. And based on which now your security analyst can analyze the packets that is being transferred from source to destination. So this is how actually you can analyze the impact of your model based on some features. So now we know which features has actually contributed more in understanding these patterns. Yeah. Yes, so, and this is references that I have used for my slides. So do you have anything to ask?